This is the Intermediate Algebra Practice Final Exam, page 3, right? Looks like we have a graphing problem. Use the slope-intercept form to graph the equation. So use the graphing tool to graph the line. Use the slope and y-intercept when drawing the line. Okay, so we have to be specific on how we solve this, or how we graph. So we have y is equal to negative 4x plus 4. We want to use the slope and the y-intercept. So really, when you use the slope and y-intercept when graphing a line, we use the y-intercept first. So the y-intercept, okay, if this is mx plus b, remember the b is part of the y-intercept. So the y-intercept is 0, 4. Okay, the y-intercept is a point, not just a number. So we go 0, 4, plot your y-intercept. And now we can use the slope, negative 4 over 1, to get another point. So the negative 4 over 1 tells us from our y-intercept, we're going to go down 4, and then the positive 1 in the denominator, go right 1. Okay, so from here, go down 1, 2, 3, 4, and the positive 1 in the denominator, go right 1. Okay, you have your 2 points. Then you'll use the graphing tool to draw a line through them. And you have your line. Okay. If you want to double check that you graphed this correctly, see where this point fell was on 1, 0. You could plug it in here. So 1, 0 means that the y was 0 and the 4 was, or the x was 1. This should be a true statement. So if you simplify, negative 4 times 1 is negative 4. Negative 4 plus 4 is 0. So we have 0 is equal to 0. It checks. We know that's another point on the line. Okay. It's not necessary to check it if you know you graphed it correctly. But if you're not sure, you know, you can always take the extra minute to check. Okay. Ooh, excuse me. Number 10. Find the domain and range of the relation shown on the graph to the right. Use the vertical line test to determine whether the graph is the graph of a function. Okay, so you might want to really pay attention to this one, because I feel like this is one of those problems where a lot of you are getting incorrect. Okay, so let's start with determine the domain of the relation. Select the correct choice below. Okay, so again, the domain is the set of all x values that are part of the relation. Okay, so the x values go from left to right. So we're just looking at this graph to see what values does this graph go through. So I'll look left to right. So here's a part of my curve, or part of my graph right here. Notice it's going to the left non-stop. There's no breaks in the graph, and it's going to keep going out to the right, which means it includes all real numbers. So the domain of the relation is the interval negative infinity to positive infinity. Notice there isn't one x value that wouldn't be included on that graph. So that means all real numbers, negative infinity to positive infinity. Okay, let's do the range. The range are the y values. Select the correct choice below. So let's see, y values, they go vertically, so we're going to look up and down. Okay, I'll start with the smaller value, so I'll start down. We didn't have to look at this part of the graph for the domain because they were all included in the top portion. But because the range is up and down, we'll look at both of these portions. So notice the ends are going downward. So that means we're coming from negative infinity. There is a break. There's a break in the graph right here, which means where does the break start? So it's a little small, so 1, 2, 3, 4, 5, 6. Okay, so -6. So this part stops at the -6. It includes the -6, so you put a bracket there. And then union, because here's the break. And then it starts back up again at 1, 2 at -2. So bracket -2. And then notice it's going to keep going up, so it goes to infinity. So this was the range that we did here. So the range is a single value. No, it's not a single value, it's an interval. The range is an interval. Negative infinity to -6 bracket, union bracket, -2 to infinity. Let's see, the graph is or is not the graph of a function. So it is not the graph of a function. You can see how the vertical line goes through more than one point. So the graph is not the graph of a function because a vertical line cannot or can, so a vertical line cannot be drawn so that it intersects the graph exactly once. So because it cannot because a vertical line cannot be drawn so that it intersects the graph exactly once. Okay, the other way, if you said because the vertical line can be drawn so that it intersects the graph more than once, can be drawn so that it intersects the graph more than once, probably sounds better to me once we put it in, once we go that route. So I would actually say I would probably do the can more than once. Okay. So that is page 3.